Excuse me. So let's look at the idea of multiplying or dividing fractions. Now, as we learned before, multiplying is the easiest thing to do with fractions if we have a basic fractions. It's top times top and bottom times bottom. 3 times 4 is 12, 2 times 5 is 10, and then of course you might have to reduce that. Okay. But let's look at something that's a little more complicated. And let's look at dividing fractions first. I don't think I talked about that. If I have 2/3 divided by 1/5, well, I'm not sure how to divide 2/3 by 1/5 right off the bat. So something has to happen here, and there's where it's going to happen. What I'm going to do is I'm going to invert this. Turn it upside down, make it 5/1. And then I'm going to invert the division sign to a multiplication sign. Now, the key is you invert the divisor, or the term that you're dividing by, which is the second number. This is 2/3 divided by 1/5. So the divided by part is what I'm going to flip or invert. Now I'm back to just plain multiplication. 2 times 5 is 10, 3 times 1 is 3, and I have my answer. So when I divide, there's an intermediate step here. And this is sort of a shortcut, but it works fairly straightforward. And when you divide by fractions, you just have to remember invert and multiply. So I'm going to invert this part and then multiply the two of them together. Well, since multiplication is just top to top, that makes it fairly easy. So let's try something that's a little more complicated. 3t over 2 divided by a over b plus 1. Well, this certainly looks complicated enough that I might want to just tear my hair out and throw the test in the basket and go home. But let's go back to our rule. We're going to invert and multiply. Okay, so we're going to change this to b plus 1 over a. And I'll tell you what I'm going to do. Instead of making this a t, I'm going to make this an a, just to have a little something else to do. So then I have 3a over 2, and I'm multiplying them now. So I inverted the divisor, and changed my division symbol to multiply. Top to bottom, top. So this is a quantity with a separator. So I have two terms over here I'm multiplying by 3a. So I'm going to multiply 3a times b, there's 3a times b, plus 3a times 1, which is just 3a. And then I'm going to multiply the bottoms, which is just 2a. Now, what I'm going to see here, and this sort of goes to the idea if I factor something out, or take something that is in common, I notice here that I have an a here, an a here, and an a here. I have an a in every term, in both terms in the numerator and the denominator. So if I wanted to factor out a out of this, I could take a out of this and a out of this, and so the a's would all go away, leaving me with 3b plus 3 all over 2. But let's go back. Let's go back here to where I was multiplying. If I'm multiplying two fractions, I can essentially draw a line straight across and say that's that quantity times that, and that quantity times that. What I see here is, since there's no separator here between these two, and there's no separator here, I could really move this 2a over here and say this is 2a, 3a divided by 2a, and then the numerator has an extra term times it. So over here I see, oh, a divides a out. The 3 and the 2, there's nothing in common. So now when I multiply 3 times this, I get my top, 3ab and 3a. Oops, I'm sorry, I took my a out. 3 times b is 3b, 3 times 1 is 3, and I have my 2 left down here, which is my 2. So lots of times it may be helpful to factor your common terms out before you multiply. All right, so let's look at something that's a little more complicated, a little tricky. T squared minus t all over 3 divided by 1 over 3t. Well, here we are, we got fractions and we're dividing. So let's invert the divisor. So I'm going to have 3t over 1 times t squared minus t all over 3. Okay, so remember when I said if I'm multiplying two fractions, I can just kind of write this off all the way across. And now it's this quantity times that quantity, and this quantity times this quantity, but 3 times 1 is just 3. So my bottom is nothing more than a 3. Well, there's nothing between these terms. This term is here and this term is here. I can essentially move this over and say this is 3t over 3, that whole thing, times that over 1. Yeah, I can do that. So then I say, oh, I've got 3 over 3, so I'm going to reduce this down. Now I just have t times that. And this is all over 1, so I don't have a fraction anymore. So now I just have t times the quantity, and I'm just going to clean this up a little bit, and I have t times that quantity there. Well, I have two terms inside, so I'm going to multiply the t times both of them. T times t squared is t cubed, minus t times t is t squared, and there is my final answer. Notice what happened here. I had a t in this term. I should say I had a 3 down here. When I inverted, I had a 3 up top and a 3 on the bottom, and the 3's canceled out. So then I ended up with, and I will talk to that idea with a more simple kind of a fraction. 5 times over 3, I'm just going to multiply here, 3 over 4. Well, I could say 5 times 3 is 15, and 3 times 4 is 12, but obviously I have a reduction here. I can divide top and bottom by 3, so that makes that 5, and that makes that 4, and I have reduced. But we're multiplying here. I have this quantity times this quantity, and this quantity times this quantity. Well, I'm multiplying two numbers. 5 times 3 is really the same as 3 times 5. So I could just move them around. So now my fraction is the same thing, except that 3 over 3 and 5 over 4, I see this as being just 1. I can multiply it times it, but then I'm going to divide it back out. So I have 3 over 3, and I cancel that. Now my answer is 5 over 4, which is ultimately where I ended up with after my reduction. So sometimes when we're dealing with fractions and multiplication, we can, and let's go back to, let's say a plus 2 over 3 times 3 over 5. Well, if I draw my line across here, I have this times this, and this times this. I could swap these two on the bottom, because 3 times 5 is the same as 5 times 3. And I say, oh, well, there's no plus between these, so I can factor these out. This is nothing more than 3 over 3, or 1 times that quantity. Well, if I take away the 1, I get my quantity. So now there's my answer. So this is the idea of fractions and multiplying and dividing and factoring out some common terms before you do your full multiplication. And division of fractions is ultimately multiplication, because we invert and multiply. And I just want to leave you with that idea. So if I'm going to divide, ultimately with fractions, I'm going to invert and multiply. All right. Have a good day.